Welcome to our new fortnightly ESCoE webinar series. I'm Paul Mizzen, Deputy Director of ESCoE. I'm very pleased to be able to chair the first webinar taking place this academic year. We're kicking off today with a presentation by Sofia, Calzavara and Haste on exploring local statistics and clustering. The ONS and other public bodies have gathered local statistics for many years, and they've been held in a variety of locations and are often hard to locate. The presentation today will explain how the ONS has fulfilled a promise made by Sir Ian Diamond at the Royal Society in 2023 to make access to local statistics easier and to free up time for decision making. I'm not going to steal the thunder of the speakers by discussing the content now, but essentially it's a tool that's designed with the user in mind, and we'll find out more shortly. I should say before handing over to the presenters that the ONS Explore Subnational Statistics team, led by Emma Hickman, won the Campion Award for Excellence in Official Statistics at the Royal Statistics Society Awards for this product, because in the words of the judges, it has considerably improved the availability and access to local data in the UK and has real potential to empower local areas, providing them with the data they need to make the right decisions. So I'll hand over now to Will and Sophia to show us more. They'll speak for about 35 to 40 minutes, and then Stuart McIntyre will discuss, and there'll be Q&A to follow that. So over to you, Sophia and Will.
Thank you, Paul. Well, good afternoon all. Thank you for having us here. My name is Sofia Calzavara and I head the Subnational Statistics Development and Dissemination team based in the Subnational Statistics and Analysis Division within the ONS. And as Paul was saying, today I'm here to present our Explore Local Statistics beta service, which we launched at the end of March this year, while my colleague will present our work on clustering UK local authorities. So if we move to the next slide, please. So before we go into the meat of the presentation, it's worth asking ourselves, what is Explore Local Statistics? So it is a digital dissemination service to find out more about local areas across the UK, and it enables users to find the local relevant data easily in a single place, bringing together more than 60 subnational indicators from publicly available datasets published across government departments. It also allows users to visualize this data and to compare it against other areas in terms of similar areas or parent areas, as well as comparing how the data has changed over time. And finally, it also allows users to reuse this data by downloading the underlying data sets or embedding charts and visualizations in their own services and websites. As Paul mentioned, we did win the Campion Award for Excellence in Official Statistics earlier this year, and we were very proud of that moment. If we move on to the next slide, why did we develop this service? So as we were sort of saying, across the ONS website, but also across gov.uk, statistics tend to be structured by theme and tend to also be scattered across several websites, depending on the publishing department. So for anyone who is interested in finding about a specific local area, there is a lot of work involved in just finding the right data in the right place, and as well as in pulling it together in one place. And so just after all of this research has happened, users can actually start their analysis. So what we wanted to do was to make it easier for stakeholders to find the data that they really need to then develop evidence-based policy, saving them a lot of time of compiling the data in the first place. It's also worth noting that a few previous reviews of economic statistics had already recognized the importance of regional statistics, and also, as you will remember, the Levelling Up white paper agenda had a renewed focus on this topic of local statistics, as well as the current government with the deepening of English devolution and a clear mission on economic growth. So we feel like the need for easily finding subnational statistics in one place is very much a continuous need across different governments. So it's worth remembering how our vision for Explore Local Statistics came about. So it was launched back in December 2021 as part of the Government Statistical Service Subnational Data Strategy. And this strategy brings together three overarching ambitions that ELS sort of embodies. So the first of these ambitions is to produce more timely and granular harmonized subnational statistics, aiming for thinking subnational by default. The second is around building capability and capacity for working with subnational statistics and for conducting subnational analysis by improving the way we share data, methods, and expertise. And you can think about this webinar as part of this second ambition. And finally, the third ambition is to improve the dissemination of subnational statistics, and probably you can more easily see how Explore Local Statistics responds to this particular ambition. If we move on to the next slide, please. To develop our service, we have followed the principles outlined by the government digital services to deliver digital products in an agile way. We have therefore iterated regularly on our designs and continuously tested our assumptions via user research. In February 2022, we published the alpha prototype of the service, which we called Subnational Indicators Explorer. The aim of this prototype was really to give transparent access to several indicators at the local authority level, in line with the metrics that at the time had been identified as crucial in the Leveling Up white paper. Then, between February 2022 and March 2024, we updated and expanded this prototype tool quarterly, and we've continued to build the foundation for Explore Local Statistics. In March 2023, we launched an MVP of the beta version of the service, which was known as the Find Facts and Figures About Areas in the United Kingdom, and was our first geography-focused journey on the ONS website, bringing together existing dissemination products with a local lens, including census maps, build a customer profile, and other products. So again, as I was saying at the start, this idea of turning upside down the journey rather than starting from themes, starting from a geographical area. So this is what beta version of our service, Explore Local Statistics, achieving our vision for a statistical dissemination service, which helps users to find, visualize, compare, and download dozens of local indicators in one place. Our journey hasn't finished though, and we are now focusing on transitioning the service from beta to live. And to do so, we are reviewing and refining the front end of the service to ensure it meets GDS accessibility standards. And we're also working behind the scenes to improve the resilience of the pipelines and processes that feed the data to the service. Moving on to the next slide, please. As Paul was saying in his presentation at the start, at the heart of the development of Explore Local Statistics, there are really the user needs of our primary target users groups. These groups are primarily analysts and policy officials working in local government as well as across central government, but also more broadly members of the general public, the media, the third sector, and I'd say also academia interested to understand more about local areas across the UK. So starting from these needs, we have developed features and functionalities within the service that allow users to understand how a local area is doing on a range of different indicators. And we cover various themes from employment, housing, education and skills, health and well-being, connectivity and crime. We've also developed functionalities to enable users to explore how these indicators have changed over time, as well as comparing across different types of areas. We'll say a bit more about our clustering later on, so I'm not going to spoil anything there, but we also have a functionality that enable users to compare with statistically similar areas. And yeah, as I mentioned, while academia isn't probably our primary target user group, we are actually quite curious to understand later during the discussion how you could see yourself using Explore Local Statistics in your work. So have a think about that while I will be demonstrating the service. So what I need to do now is to swap to another screen. So give me just 1 second to do that. And later in the presentation, we will also be able to share a video demo with a demo similar to the one that I will be doing now. So hopefully you can also refer to that in the future. So just 1 second. Windows. Okay, can everyone see my screen correctly?
Yes, it's showing up for me, Sofia.
Fantastic, thank you very much. Right, so here is the homepage of Explore Local Statistics, and I will start this demo by talking about navigation. So the Explore Local Statistics homepage provides users with two options. You can search for an area by typing in the Find an Area box, or you can browse the different indicators available group by topic. So for example, I will start by typing Newport, and then clicking on this magnifying lens. This takes me to the start of the Newport area journey. If I scroll down this page, I can see a variety of products that are available to look at data for Newport. But I also have this blue tile on the right, and when I click on Explore Local Indicators, this takes me to a data-rich page that we launched in March. So this page provides me with a default view of the data available for the area I have selected, and a lot of functionality I need to view and create different data visualizations. Just like the Subnational Indicators Explorer, the indicators are presented vertically and are grouped by topic that you can also jump to using this menu on the left. If we go up to employment, here you can see Newport's labor market data. For each indicator, we have two visualization elements. The first one on the left shows the distribution of areas using the median absolute deviation. And each circle represents the local authorities, and areas with low values are on the left, while areas with high values are on the right. Newport is then represented by this blue circle, and I also have a comparison, in this case the median of all local authorities available in the distribution in purple. If I want to change comparator, I can navigate up to Change Areas button, open the primary comparison, and select, for example, Wales. Similarly, I can change which other areas are showing in the Related Areas section. So for example, instead of seeing all local authorities across the UK, I can choose to just see local authorities in Wales. So you can now see the distribution has changed. On the right-hand side, we have a line chart, and the label indicates the absolute change for Newport over the time period. If I go back to clicking on options, I can also tick this box to show confidence intervals. If confidence intervals are available for the dataset I'm looking at, these become visible both on the beesworm chart and on the line chart on the right. I think the final thing I want you to note on this section is that if I click on this info button, you can find more information on methodology and metadata for each indicators, which helps you to understand how an indicator is measured and how it should be interpreted. Now, if we jump towards the end of the page, we have this Select an Indicator section where you can dive deeper into the data for one specific dataset. So for example, if I select level 3 and above qualifications, I can choose to view the data on a time series, on a bar chart, or on a map. But as you can see, the default views, for example, particularly for the bar charts, might not be so useful. So really what you need to do here is to customize your chart to get what you might want to visualize. So for example, if we decide to only look at other local authorities in Wales, and to also include Wales as the comparator, this becomes a much more useful chart. Similarly also for the time series. And as we've seen previously, we can also implement confidence intervals, visualize them on the chart. I guess charts like this are very useful if you can reuse them. So that's why we have also included an embedding code option, as well as the option to download the line chart or the underlying data to the specific chart. If we now scroll to the similar areas sections, in this particular area of the service, you can look at the statistically similar areas based on Newport, and you can do that across different clustering models, which we'll discuss more in detail, including the economic, demographic, health, and connectivity indicators. At the bottom of this section, you have a small description of that particular cluster, and you can also open this drop-down to see all of the other areas that belong to the same cluster of the area you've chosen. So in this case, Newport. Excellent. So now I will move on to the second journey. So I will go back through the home page. And instead of looking for one area, I will click on Local Indicators, Explore Indicators. So this brings me to the indicator-oriented journey. I can, for example, here choose to look at gross median weekly pay. And while previously we were looking at one specific area across different indicators, here we're looking at one specific indicator across different areas. So what I can do again, I can customize the way in which I look at the data presented. So for example, in this case, I can decide to switch to a countries and regions view, or also change the year of the data that is visualized. And again, I have the option of changing the areas that I'm looking at and highlighting particular areas. So let's say, for example, I want to highlight Northwest and Northeast. This is then automatically translated onto the below charts. So again, we can limit the number of areas that are visualized to just showing all regions. And again, we can implement, for example, confidence intervals on a line chart and on a bar chart. Finally, we have this interpretation section that gives a bit more information on the particular indicator that you are exploring in that moment, and specifically also the original data sources it comes from. And we've also implemented the option of including a download dataset where you can basically download all of the indicators across all of the areas available in the service in just one big download. That, as you can see, it's 4 megabytes, so it might take a long time to download, but once you've done it, you will have all of the intelligence that we've gathered across these indicators in one place. And I think this brings me to the end of my demo. So I will stop sharing that screen, and I will now share another screen so that we'll can do his part of the presentation, but actually I do have one more slide which I need to present. So give me 1 second. So before I leave the word to Will, just a very quick view on what's happening next with ELS. So our focus since the launch in March is really been around promoting and raising awareness among our target users and broadly stakeholders on the service. So thank you very much for having us today, because this is part definitely of raising the awareness point. Then, as we were mentioning, we are still conducting user research on the live service, and this is crucial for us in order to iterate and improve the current functionalities and move more confidently from beta to live later at the start of next year. We're also continuing to add the new subnational data sets, and particularly we are focusing on filling gaps to create a UK-wide coverage as much as possible. And we are continuing to improve the resilience of the data pipelines and processes behind the scenes. So I think this brings to the end of the ELS section. So Will, over to you.
Thank you, Sophia, and thank you to everyone who's come along today for taking time out of your afternoons to listen to us speak about our platform. So my name's Will Haste, and I'm the clustering lead within the team, and I work as a subnational methods analysis within subnational methods analyst within Sophia's area, just as a brief introduction. And today I'm going to be taking you through some of the methodology that goes into our select similar areas, a feature of the ELS, which is part of our clustering UK local authorities work. So if you could just pop onto the next slide, please, Sophia. So before we get into the sort of meat and bones of it all, I'm just going to go through some of the project aims that we initially sort of had when we started this work. So we received a steer from some of our subnational stakeholders that similar groups of local authorities would be useful to them, so that they could just for use within their own analysis. And we decided to use k-means clustering to generate these groups of UK lower tier local authorities with similarity across a range of topics. So as you could have seen in the ELS presentation, we produced a global model, which is for an overall measure of similarity across a variety of metrics, alongside 4 specific topic level models. These were an economic model, a demographic model, a health and well-being model, and a connectivity and sustainability model. Now, we've had this work going for a little while, and I wanted to also take you through some of the applications of this work before we go into it. So firstly, these groups can be used to provide counterfactuals for policy impact analysis. Now, this can take a very simple form of a local government analyst just taking the clusters and looking for a similar area within their local area, which they can use to sort of compare policy outcomes against, or this can be much more theoretical and involve looking at synthetic control analysis and techniques like that, which would involve taking all of the similar areas that, or a subset of them, which did not implement a certain policy, and weighting them to try and sort of create a counterfactual for the area of interest, and then using a bit of a differences application to look at how the policy has impacted the outcome variable over time. So that's the first use, but they're also valuable to use as subnational groupings themselves. So because they hold factors constant, if you were, say, interested in looking at how housing is different across different demographic areas, you could use the clusters themselves and compare any differences in outcomes between the different cluster areas to look at, say, how, as I said, demographics affects housing availability, which is one example of how this has been used. And a third and final application is that these clusters actually do have quite a lot of intrinsic value just in themselves. It's interesting to observe and look into the subnational trends within each cluster. They can tell you potentially a little bit about the geographical drivers behind the different sort of metrics that are included in them. And they are also useful for analysts to look at similar areas on Explore Local Statistics and the inquiring citizen to just look into a little bit about the sort of world around them, really, a bit of intellectual curiosity. If you could move to the next slide, please, Sophia. Just before I go into more depth, I'm going to run through a quick introduction to k-means clustering for anyone on the call who hasn't used the technique before. So k-means clustering is an unsupervised machine learning technique that identifies and groups similar data points within a data set together. So this is represented in the visualization on the right of the slide. And if you imagine all of the metrics that are being put into the clustering model being mapped out in multi-dimensional space, the algorithm generates a number of k random centroid points, and then each of the individual data points are allocated to the closest cluster with the distances stored. And once this is done, the centroid points are updated to be central within each of those initial clusters, and then the distances are recalculated, and the whole process is iteratively repeated until the Euclidean distance between all of those different points is minimized across the whole sample, and we've reached our final clusters. So for our analysis, we used a sort of iteration maximum of 300 because we didn't want to take too much of our computer's resource on it. And a lot of the research says that with k-means clustering, after about 70 or 80 iterations, you are normally at that final point. So we thought 300 was a good sort of point to set for that, allowing for any potential idiosyncrasies in the model. As well as that, we initialized the model 10,000 times. So that means that we started with 10,000 different groups of random centroid points. And with that, we were confident of once that our clusters were, the best solution was taken from that. And that proved that there was quite a lot of stability within the cluster, within the sort of output that was formed. We use Python to code that, a bit of a technical point, a bit of a sort of boring point, but it's sometimes important to mention these things. And we use the sklearn package for most of our machine learning work. This is a brilliant package. I'd heavily recommend anyone who wants to use some machine learning techniques to use it, and there's lots of documentation around it. As the ONS, we think that transparency in our work is very important. So after the fact, we cleaned up some of our code, took out some of the sort of more confidential parts of it, and published it on our public GitHub. So that a link to that is in this presentation, and anyone who wants to maybe look at how we did our work and apply it to some of their projects, you're more than welcome to view that and ask any questions to me after the session or in the Q&A section about it. Our models, were set to produce the minimal Euclidean distance and the optimal number of clusters between 4 and 15. So it's a little bit of a negative sometimes with these clustering techniques, that there can be some subjectivity in how many clusters are sort of chosen by the analysts. So we wanted to take that subjectivity out of it. And so we used silhouette scores, which is a measure of how distinct the clusters are, to inform the number of clusters that we chose in the end. So we ran it for all between 4 and 15, and we chose those thresholds between because when you're looking at less than 4 clusters, those groups are a little bit too broad to do anything interesting with. And when you're looking at upwards of 15 clusters, you'd start getting pockets of very, very small local authorities where you wouldn't be able, it wouldn't add too much. You wouldn't be able to do too much analysis with them. So that's how we settled on our range of K for this project. Could you move to the next slide, please, Sophia? So now we've talked about the method a little bit, we're going to focus on the data that we included in the model. So we used as a starting point the feature that Sophia showed you about ELS, and downloaded all of the data and started going through it and selecting which data was suitable for our models. So the things that we were prioritizing within that process were full UK coverage. We wanted to have cluster data for the whole of the UK, because we thought some of the most interesting results would be how areas in each of the nations compared to other areas within the other nations where there might be some sort of unexpected similarities and differences. We also were looking for data which had very low missingness, because the k-means clustering algorithm does not process missing data particularly well. So when there was a missing local authority, it was removed from the final output. So for any of the metrics. So we had to look at complete data, and also we did a little bit of work of plugging those gaps within data sets that we really wanted to use by imputation and other methods when there wasn't another option. We supplemented the ELS data that we trimmed down into the suitable metrics with some data from other government departments, and We also, when we had England only, or say England and Wales only data, we worked quite extensively with devolved administrations to find methodologically comparable data for those metrics which they might have produced but not from the same source. Once we'd decided that the metrics might be methodologically comparable across the nations, we then did some distribution checks on the data just to affirm that and make sure that there weren't any particularly troubling results between the nations. Because obviously, if we're including data which is very, very different because of something in the collection between different nations, we run the risk of the clustering model just outputting the 4 UK nations as the as the 4 clusters due to data differences, and obviously that would not be adding to any of the subnational products that are already out there. So we wanted to remove that as far as possible. Now, once we identified all this data, we wanted to we did some analysis of the data's interaction with each other and a principal component analysis on some of our initial results. So this was important to us because even though you can put correlated data into k-means clustering algorithms, it might weight the output unnecessarily towards those correlated metrics. So it wasn't a strict exclusion criteria. Where there was some we had quite a high correlation threshold, and when there was some correlation, it's to be expected in a lot of these variables. So we weren't absolutely draconian with it. But where there was one variable, like the one on the screen in the table, which is country of birth, that is correlated with multiple other variables very highly, we decided to have a look at the PCA of them and potentially take them out of the model. We did this with country of birth, and also within our wellbeing metrics, we started off with 4 wellbeing metrics, the standard 4, but we found that the results of these metrics was too important within the models for our intentions, so we ended up removing one of them. If you could go to the next slide, please, Sofia. So now I'm going to move on to talk about some of the data cleaning and transformation that we had to do to get the data set in a state to produce the best results. So one of the issues that we had is we used the most recent available data whenever it was possible, but sometimes this data fell in different years. Now this caused an issue with the geographies because there were quite a lot of changes to the local authority boundaries between 2020 and 2023. Several instances of lots of smaller local authority districts forming to create new unitary authorities. And as a result of that, because we had data spanning a few years, we had lots of data that included some geographies but not others, and we had to come up with a weighted imputation method to convert all of the data with the old local authority boundaries to the new 2023 local authority district boundaries. You can see on the right hand side here how this affected our output. So the top right is the first map that we ever took out of our clustering model, and as you can see, there's quite a lot of missing data in there. Bristol seems to have been flooded, and Scotland is cut off from England and floating up towards the North Pole, and lots of things that we do know not to be true. So we had to figure a way out to fill those gaps, and that's where we came up with the weighted imputation method. The next problem that we had was, as some of you may be aware, that k-means clustering doesn't deal particularly well with extreme values. So a big example of this would be in our connectivity and sustainability model. Before we'd come up with a methodology to deal with these extreme values, we had the City of London forming a cluster completely on its own, a one local authority cluster. This was driven by a very high result in CO2 emissions, and it was something that the model had naturally come to. But obviously, it's not a particularly useful thing for us to put out there for a City of London analyst to say, you have no similarities in this aspect with any of these other areas. So we wanted to come up with a way to reduce those very small clusters that we had to sort of at the top of lots of our models, and basically take those very extreme values and convert them into a less extreme value that would still take into account the true result that we were seeing in that area, just not make it so that the difference between that area in that metric was so big that it crowded out all of the other interesting things and interesting variations that we were looking to see in the model. So we assessed the success of these transformation techniques that we were testing by whether or not it broke up those clusters and how they impacted the silhouette scores and the cluster distinctness in general. So the first two that we tested were inverse hyperbolic sine and logarithmic transformations. We found that these had marginal success in breaking up the small clusters. It would change, say, it would sometimes change a 3 local authority cluster to a 5 local authority cluster. But with that, it wasn't particularly effective in, neither of them were particularly effective in that, and they also severely reduced the cluster distinctness and the silhouette scores. So the one that we actually settled on was Windsorization. Now, Windsorization is a technique which involves basically trimming your data. So it sets any value below or above a certain percentile to the value of that percentile. And in that, it preserves any result as very low or very high, just not so high as it was distorting the models. So for our project, we chose the first and the 99th percentile as our Windsorization thresholds because we really didn't want to sort of alter the trends and the true trends that we were seeing in the data too much. And with that, it was very successful in it basically didn't change the silhouette scores at all because 98% of the data wasn't being altered in any way. And also it increased the size of the smallest cluster from the smallest cluster initially was, as I said, 1 local authority, and in the Windsorized models it was 26 local authorities, which is a much better size to do some interesting analysis with. If you could move on to the next slide, please, Sofia. So I'm not going to go through all five of our maps and models in this call because we'd be here past one, and also a lot of them show very similar trends to each other. But I am going to focus a little bit on the global model and how the subnational what clusters we saw and how they are characterized subnationally. So this is the overall model that included all of our facets of metrics, and it produced these clusters. Cluster A, which you can see in blue, is a very rural cluster. Basically, every rural area that's outside of a commuter belt was included in this cluster, and it was interesting to see this pretty consistently across the economic and the demographic models, specifically that the rural areas are much different to these commuter belt areas and the urban areas. There wasn't much sort of interaction between the clusters on those ones, and the characteristics of these clusters, these areas, are that they have older residents, lower ethnic diversity, and very high well-being. Cluster B, which you can see in orange there, is our commuter belt cluster. As you can see, it's mainly centered around London, spreading out into the surrounding areas, and there are also pockets of orange around Edinburgh, Manchester, and Birmingham, which further suggests that these are areas that are similar because they're very, very close to, or not necessarily in London's case, but generally they're close to a big urban conurbation. If you see cluster C, it is in green. Apologies that it's not that different to the blue. This is what we called our current and past industrial heartlands cluster. So if you look at it, there's quite a concentration of local authorities in South Wales, and then a band of local authorities across the north, and some in the northeast as well. And these include a lot of our sort of current and past manufacturing and secondary and primary industry sites, which and the fact that it had sort of, and this is not a commentary on these areas at all, but in general, what we saw from this cluster was that it had lower GVA, higher children in relative poverty, and a low life expectancy, which maybe tells you something about how the trajectory of these areas has been altered as the sort of industrial makeup of our country has shifted over the decades. And then our final cluster there in red, which isn't as visible, but there were quite a lot of areas in this cluster. It's just a very urban cluster. This was largely centred in London, with a couple of other areas popping up again in Manchester and Birmingham. And these were very high GVA cluster local authorities, which were very ethnically diverse, with lots of people with high qualifications and a high working age population. But perhaps unsurprisingly, I live in London, and I see this could be true. It had the lowest well-being out of any of the other clusters, so it's not all sunshine and rainbows in Cluster D. Now, before we move on to our Q&A section, I'd like to say that this clustering output it's an evolving product, it's a live product, and we're just entering our next iteration of it, hoping to publish some more analysis at the beginning of next year. And with that, we're looking to integrate further geographies into this model, not just the lower tier local authorities, and also include a nearest neighbours feature, so that somebody who wasn't so much looking for a broad group to analyse, but wanted a specific ordered list of very similar local areas that they can directly sort of collaborate with, that will hopefully be available within our next publication. All right, well, thank you everyone for your time, and I look forward to taking any of your comments or questions in the next part of the call.
Thank you, Will and Sophia. So remind us to everyone that you can put questions in the Q&A section, so please do make use of that. But we're first of all going to hear from Stuart McIntyre, who's going to discuss the paper. Over to you, Stuart.
Thanks, Paul, and thanks, Sophia and Will, for that presentation. It was really interesting to get that overview of the work that you've been doing, and I think it's, for me, obviously in a university rather than local government, but it's good to see the investment in making these sorts of data more accessible and easier for stakeholders to access and process and do some analysis with. I think that's a real asset of the investment that you've done. And I also really like the fact that you'd embedded the confidence intervals within some bits of the analysis as well, because again, as we all know, particularly when we get down to more granular spatial levels, the confidence that we have in the economic data decreases, and we have wider confidence intervals. And I think particularly when we start trying to do analysis at that lower spatial scale, it's really important that that issue is really front and center in how people are using and interpreting these data. So it was really good to see that. I guess a couple of different areas that I thought were worth perhaps opening up as potential topics for conversation. I think one is perhaps a sort of bucket around how we might extend what you've already done. So, for example, thinking about that sort of clustering analysis and whether doing that clustering as you've done based on, say, the level of particular variables versus doing that kind of clustering on the trajectories. Because I can imagine within some of these local areas, even areas with similar levels of economic activity just now, or similar levels of deprivation or anything else, could be on quite different trajectories. And therefore, doing this sort of clustering not on levels but on growth rates and longer term growth rates in some of these variables might be interesting. I wonder if you've thought about that at all. Another thing would be whether or not it's possible to perhaps try to pull in some other data into this platform. I know there's lots of other aggregate data out there, but there's also other micro data that you could pull in and present as an aggregate and have this as a dissemination platform for local data. So I was curious if you had any thoughts or plans in that direction. I think it's really good that the code that you've made available, the code that you've used is being made available. I guess for many of the users of these data and colleagues in local and central government, they may not be running Python. That may not be a language that's native to them. So I just wonder, has there been any thought about trying to embed within the platform the ability to actually rerun some of this clustering analysis, changing the variables that are included, just to, again, expand that flexibility for colleagues? And then I think probably the second kind of bucket then of thoughts that I had were really around where does this go now in terms of use? So there's how we perhaps take what is already a mature platform and extend it, as I talked about, but also how do we then build in features that support it as a decision tool? You know, that point that I think Sophia made earlier about Ian Diamond's wish that this was supporting local decision making. How do we do that? We'll talked a bit about trying to extend this in the direction of other ways of producing counterfactuals, which could then support impact and evaluation work by stakeholders, particularly in local government. So how do we take the next step with this and really strengthen it as a decision tool, building on the foundations that we've got? So I guess in summary, it's great to have this. I think there's a number of different ways in which we could extend this. I'd be really interested in any thoughts from Sophia and Will around how we might try to support this more as a decision tool going forward. Because it's really nice to have the platform and the data and the visualizations, but how do we take this forward to support decision making at a subnational level?
So
Thank
thanks
you.
very much, Stuart, for that. Let me give Sophia and Will just a couple of minutes to respond to those points, because we've got some questions in the Q&A as well.
Thank you, Paul. I will be very quick. So on your point, Stuart, around how do we move it from just being one of the many services to actually being crucial and helping users, I think we shouldn't underestimate the amount of work that is required to engage users and raising awareness and making sure that everyone is starting to embed this product into their working lives. And in that, I guess it's worth considering that within the ONS, we also have a sister service, which is much more a people-based service called ONS Local, where we have analysts embedded across the regions of the UK, regions and countries of the UK. So we very much see Explore Local Statistics as being the digital arm of a much wider service where ONS is supporting local government to find more easily the evidence they need to then enable local decision making. Obviously, always keeping in mind that ONS has to be neutral towards any sort of policy decisions.
Anything from you, Will, on any of those questions, or shall I move on to the Q&A?
I'll just very quickly come back on a couple of Stuart's clustering specific points. In terms of the sort of live version of it, where a user can select their own variables, that was something that we discussed for this iteration of the analysis, but I don't think that it's currently in the position where we're going to be able to sort of host that sort of functionality where it would be currently going. Was the outcome of that discussions. It's definitely something that we want to keep on the docket and look at for future parts of this work, but I don't think that we're quite there for the next section of analysis. And similarly with the sort of clustering around trends, it is again something that we have explored in the past. One of the big blockers on that, unfortunately, is the quality, is the amount and quality of subnational time series data at the right level. Looking at, there's been quite a lot of work in the last 5 years on getting these local indicators out at a lower geography, but it doesn't necessarily, for a lot of our metrics, extend past that. There's definitely some work that we could do on it, but it would be because we've already got quite a number of factors which trim down the types of data that we can use, including the sort of UK comparability and missing list points that I raised earlier. With that, we looked at it and we thought there just wasn't the sort of bank of data yet that we could call on to do the same sort of thing that we've been doing. It's definitely somewhere I can see the work going in the future, and especially as that sort of bank of time series subnational data grows. But yeah, where it currently stood, there are a few key metrics that we could have included in it, and it would be very interesting to see how that worked out. But unfortunately, there wasn't quite the same the same availability that we had for the non-time series sort of snapshot models.
Great, thanks, Will. So let me now turn to some of the questions in the Q&A. So Jagdev Verdi has asked a question regarding adding more data sets. Can you say anything about what the priorities will be? And particularly, he would like to know about census and other population statistics.
Yeah, so I think we are currently at a slightly resetting time where obviously the new government is still defining more in detail some of their priorities. So we have for now focused on, as I was mentioning in the presentation, filling some of the UK-wide gaps of existing data sets rather than adding many new data sets. But I can see that in the next few months we will have a better understanding of what data sets or additional data sets might be needed to inform local government to inform their own policy decisions. So we are keeping a very close dialogue with our counterparts in other government departments to be reactive to any new emerging priorities. Yeah, sorry, I forgot the second half of that question, actually.
It was about whether you could use the census data.
Oh, yes. So as far as census is concerned, the reason why we haven't necessarily added census there is because we have a wealth of existing dissemination services which are specifically focused on census, and that, for example, census maps and build a customer profile that really give to users the possibility to make use of the richness of the granularity of the census data. So while our service focuses much more on local authority levels, unitaries, combined authorities, with census maps and build a customer profile allows you to explore data at a much more granular level. So we see that as part of the same geography-focused journey. So in fact, they are linked at the bottom of our Explore Local Statistics homepage. But yeah, the separation comes from a slightly different functionality for slightly different user needs.
Great, thanks. Now, there are two questions about the clustering. I imagine Will want to answer this one. So first from Anna Fock, who asks, are you able to test the significance between the clusters? So it's a between question. But then there's a second question from Duncan, which is, what about within clusters? How about the variation between local authorities within the clusters that you form? Are you able to say anything about that and explore those characteristics?
Yeah, for sure. Happy to go back on those. So in terms of significant testing, that's not something that's been part of our analysis so far. It's definitely something that we'll be looking to add in the next side of it. We've done, like, as I said, the silhouette scores, which are a measure of that, so of how distinct the clusters are, form quite a large part of the work that we do in underpinning it. And also sort of our knowledge as subnational analysts goes a little bit into validating the model. We did quite a lot of work on looking at the trends and seeing if that is something that if that was something that we were sort of happy about. So it was a bit more of a qualitative validation than the formal sort of significance testing, but that's definitely something we'll be looking to integrate into the future. And I completely agree that sometimes there aren't great differences between clusters, and some of our models show that better than others. I think that there are one or two of our models, like the demographic model, for instance, where there are very large demographic differences between local authorities, which are quite often sort of place-based in our across the UK, and with that those differences are quite and the trends are incredibly clear within that clustering model. But something like our health and well-being model, there was a much less visible subnational trend within that, and that was one of the ones that we're actually considering discontinuing, because we're not entirely sure about how distinct all of those different clusters are within that model, because of the breadth of data that we were able to include. There's not a great wealth of health data that is at the UK level, because of how devolved the policy area is across the nations. And on the second, sorry, could you direct me to the second?
The second one was really about, so it was about the differences within the clusters as opposed to differences between the clusters. So the fact that clusters may be compositions of very different types of local authorities with different population sizes and other characteristics.
Yes, it didn't form. It actually, we did a little bit of analysis on that in our first clustering publication, which didn't form, but it did not form part of this analysis because we didn't release an accompanying article on the results. It was more to do with the trends within them. We do some work when we're like naming and writing the descriptions of clusters. We do quite a lot of work on looking at the, like, as I said, you can see within my sort of description slide when I was talking about each of the different clusters, there's a lot of analysis within that, and there was some range analysis in our initial thing just to see how different the areas were on those given metrics. It's not something that I think is completely on our radar as a sort of essential criteria for our next project, but I think it's something that we definitely will do as part of our like sort of post-clustering like analysis, just to make sure everything. There are quite a few checks like that, just to make sure that like it's quite logical what's going on within there, and there aren't sort of values that really look like they're in the wrong cluster that are raising alarm bells. So yeah, it's one that we do implement elements of it, but it's one that we can definitely do a little bit more work on formalizing exactly the process, and I'll take that one away and add it to our work plan for next quarter because it sounds like a good thing to do.
Okay, and then finally, I think we've only got 2 minutes for this one because we're getting to the top of the hour. There are a couple of questions here about whether this will replace data sources like NOMIS, and given that the analysis is essentially aggregating and clustering information from various surveys and so on, what confidence do you have in those survey data sources, given that some are experiencing declining response rates? So quite a quick response to that, if you can.
Yes. So I think the reason why we are so keen also making sure that there is a way to display uncertainty on our product is exactly because we recognize that when we are working with subnational statistics, there are a lot of factors to be considered, including the quality of the service and how they evolve across time. So we obviously work very closely with our colleagues in ONS to make sure that we are always displaying the best data that is available with the right caveats and communicating uncertainty in the right way. So yeah, from our perspective, our main aim on that is to be transparent on any limitations of the original data sources. But as you might have seen, we work with a lot of data sets, not only from ONS, but also other government departments. So it is in itself a big job, the one to making sure that all of the uncertainty and methodological caveats are communicated effectively. In terms of wider point on NOMIS, I don't feel like Explore Local Statistics is a direct replacement of NOMIS. NOMIS fulfills a different type of functionalities. That said, the wider ONS has an aim to improve our website. So something might come on that later on in the future, but there aren't any particular specific plans set on that yet.
Great. Well, thank you so much. I really appreciate your presentation. Thank you, Sophia. Thank you, Will, and also Stuart for your discussion. I think we've learned a lot about the accessibility of local economic statistics and the ways that clustering can really inform decision making. I'm sure I'm speaking on behalf of many of the people in the audience that this tool will be very useful to users. So let me just close this webinar now with a reminder that the next webinar is on the 17th of October. The topic will be Treatment of Preventative Medicine in the National Accounts, A Case of Diabetes by Martin Wheel and chaired by Darren Morgan. So please do make a note of that and future fortnightly webinars that are on our website. Thanks very much.